Dr. Keller, are you there?
I am here.
Hello.
Hello, welcome.
I think we're supposed to just get started, aren't we?
All right, I think it is time for us to get started. Fantastic. Look at these wonderful pictures, Dr. Story. Thanks for
I
sharing.
found these online about a year. Well, November, I think I made this original presentation. Let me stop sharing so we can just talk.
All right. Well,
Can
let
we
me
talk?
first welcome our guests here. Let me welcome people who are joining us. Friends and family are here. I see some names I know, lots of students, which is great. I'm seeing some faculty members and staff as well, and I want to welcome all of you. I'd like for us to sort of pull back a little bit. So first of all, I'm Greg Keller. I am the chair of the Life, Health, and Physical Sciences at Gordon College, and I'm in biology with Dr. Story. And I'd like for us to just sort of pull the lens back a little bit, zoom back, and I'm going to share a few things as we get started here tonight and sort of give you the ideas that we're going to be going through. We've all been challenged for the past 18 months. It's a situation that we're now in that we thought might be over by now. When the pandemic first started, I told my boys it was gonna be rough and that it might last a full month. And wow, was that ill-advised advice. No one was prepared for what was to hit and how long it was going to last. And we're done with the days of spraying our groceries and stockpiling toilet paper, thank goodness. But we're nowhere near the end of this pandemic. And normalcy has kind of returned, but not entirely. A year ago, we were praying for a vaccine, convinced it would lift us out of this horror. And since then, we've seen hateful and hurtful arguments and political debates about masks, struggling with the reality that 638,000 people have died in our country. It's the population of the city of Detroit or Las Vegas. 638,000 families mourn. Our students have been affected. We have some positive cases on campus. Maybe we have friends and church members who have been affected, who tested positive and maybe had some serious illness. Maybe we've attended a funeral in the past few months. I certainly have. We've been affected psychologically and socially, and yet we still continue to debate and to argue. So we can convince ourselves that there has to be a solution here. Hydroxychloroquine, ivermectin, bleach, UV radiation, colloidal silver, garlic, vitamin C, vitamin D, zinc, all unproven and several incredibly dangerous. I'm sure we'll hear from Dr. Story on that one, but we want a solution. Many of our students have graduated and gone on to work in the medical fields, and they are the patriots. Long hours in difficult conditions, trying to pull us out of this.
Some of our current students are working in hospitals right now.
Absolutely, lots of them, nurses and doctors. And we've been given a gift by people in our country who seek to pull us out of this pandemic. It was what a lot of us prayed for. We thought it was the answer to our prayer through the work of scientists and researchers that God called. Many of us are skeptical appropriately and worried about side effects or troubled by the speed at which the current and past administrations push this through. It's turned political and ugly, and the amount of misinformation is staggering, with people turning to false stories on Facebook rather than trusted sources like the CDC or the Mayo Clinic, the Cleveland Clinic, MGH, Johns Hopkins, the New England Journal of Medicine, AMA. I read last night that the CDC is telling people that masks don't work. A story easily debunked and clearly false. A message that was circulated by people who probably want to do us harm. So tonight, our goal is pretty simple. We're going to remove politics, remove debates, and share what we know is true from a scientific perspective. It's not a debate tonight, and hopefully that's refreshing to get away from some debates a little bit. It's just me and Dr. Story tonight. We're both scientists, Christians, and we're both vaccinated. We're not giving time to somebody who's going to counter our message, because we are going to provide factual information here that's we're not going to debate. We simply want to share with you, those of you who have questions. Maybe you're hesitant to receive the vaccination. Maybe you're not sure what some of these really fancy scientific words mean, and you kind of feel like you should, but you're embarrassed to ask. That's where we are tonight. So it's simply a conversation between me and Dr. Story highlighting science. And I see several TSC students here, which is great. And in TSC, our scientific enterprise class, we talk about scientific literacy and what it means to be a thoughtful critic and a skeptic, and how we follow the science rather than starting with a conviction and then chasing misinformation of data or misinterpretation of data to try and support that, how we avoid confirmation bias. Gordon is running a vaccination clinic on Thursday, and we thought that for our 30% of students who are not vaccinated, our 5% of faculty and 10% of staff, that there might be some questions that you might have. And so that's where we are tonight. We have no other agenda than that. Now, clearly, Dr. Story and I both know we are biased. That's true for us as citizens, as Christians, as people. But scientifically, we want to present to you what we know, and that's what's important. So if you have a question, click on the Q&A and you can ask us that question. Click on it to be anonymous if you don't want us to know who it is, but nobody on the call here will see your name, and I will not share the questions with the group. You might not hear your question verbatim because probably several people have the same question. So I'll sort of summarize some questions together. But I want to first introduce, before I ask the first question, I'm senior, I want to introduce Dr. Story. And Dr. Story is our biochemist, immunologist at Gordon College, highly trained, teaches wonderful classes that all of you should take students. He's also our health professions advisor. He's been my colleague and friend for 14 years now, but he's been at Gordon College for 20, I think. Is that right, Dr. Story?
I think I'm going on 20, something like that. I lose track.
All right. Fantastic. So Dr. Story, it's good to be with you tonight as always. And I want to start with a question for you so first I'd like to start with a few questions just about the vaccine action. And I think this is a good one because maybe some of these words and ideas aren't familiar to people who aren't deep in. So the very first one here I see, does mRNA change our DNA? And actually, what is mRNA as a vaccine? And are there side effects from this molecule? Maybe you take that one on first.
Yeah, excellent. I got a note that you're bouncing your screen around, so try not to get so excited, will you, Dr. Keller? He's excited, everybody.
I'm trying not to. Sorry about that.
That's okay. So, yeah, funny. mRNA, something that us biologists teach our freshman students about, and people learn about it in high school biology class. It is the information that cells use to manufacture a particular protein. So it's sort of an instruction or a recipe for making a new protein. And our cells make messenger RNAs all the time. They're manufactured in the nucleus of our cells, then they go out into the cytoplasm of our cells. You've probably heard of those words, maybe if you've studied any biology. The bottom line is that this message or this messenger RNA is the message telling the cell, make this protein. The trick of the vaccine then is to introduce this outside message through the vaccine, a pre-made messenger RNA. And the first trick is to make the right one, right? So that it makes the right protein, but then you have to get it into the cell. You have to deliver it to the cytoplasm. And so we're going to talk further about how that's done when we talk more about the vaccines. But basically, mRNA is a very, very normal cellular molecule. The other thing people should know about it is it doesn't linger around. And getting to your particular question, it does not have any mechanism to insert itself in our genome, in our DNA, or change our DNA. So there's just no known or even imagined way that can happen, knowing what we know about how cells work. It doesn't work that way. It goes from the DNA to the RNA, not the RNA to the DNA, at least for messenger RNA. Right? Say again?
We don't have the machinery for that, right?
Yeah. There are viruses that have a special enzyme called reverse transcriptase. These are retroviruses like HIV. They bring their own enzyme in to reverse transcribe a particular, their own RNA genome into DNA. And then that can be inserted. But that is a very special RNA for that virus and a special protein for that virus that can do that. I'm getting a little maybe beyond the scope of your question. The answer is there's no mechanism for a regular cell of your body to take a messenger RNA and convert it into DNA and do something with our DNA.
And it's a fantastic technology. I mean, it's an amazing technology that has been used for almost 2 decades now. So it's not recent technology as we think about the most recent developments in our science, but it's been around for a while, which is really good. I see a few questions I think we can answer quickly here. The first one, which vaccine will be offered at the clinic on Thursday? And I'm almost certain that is the Pfizer vaccine, because we'll also have a second vaccine clinic in 3 weeks after Thursday for the second shot. This is a good question, Dr. Story. What about people who've never been vaccinated at all? Is there a higher risk to them?
A higher risk of disease, of getting illness?
No, I think the question here is for people who've never been vaccinated of any sort, Is there a special concern for them, or is this vaccination okay for them?
Yeah, so vaccines are always tested very thoroughly before they're approved, as we've seen for this vaccine. It went through rigorous testing. In fact, the reason it didn't come out within a month of development is because they were doing all the testing. So yeah, there's no reason to think that any particular vaccine would be unsafe for anyone. And you are continually bombarded by many pathogens, viruses, normal other coronaviruses that cause colds and things like this. And your immune system is always fighting those off. And so a vaccine is going to provide a tailored, like a mini pretend infection. It's not an infection. It's just it looks like one to the immune system and tricks the immune system into creating antibodies and immune cells, T cells. So I can't think of any, there's no reason why a vaccine, if you've never been vaccinated, why you shouldn't be vaccinated to any particular vaccine. I mean, the sooner the better in this case, because right now we have this disease floating around, right? So of all the vaccines you would want to get, the one you would want to get is the one where you might get sick from whatever it is that's out there. And this is what's out there right now. Yeah.
It's the one right in front of us.
Yeah. I mean, it surprised me that this is the one that people are the least, in favor. Some people are most skeptical about, because it's the one that I personally rushed out to get as soon as I could. May 1st was my date, and I remember that like it was yesterday, because I was just waiting, and I couldn't get it because I was not old enough, or I wasn't in the right group. As soon as I could get it, I got it.
Yeah, same here. I refreshing that page on the web page to try to.
And y'all, I study immunology. I understand the biology of the vaccines and this stuff, and so I rushed out to get it. So that should tell you something, I think. I mean, that is telling.
This is like, let me shift here a little bit. This is a great question. It's one that I thought of before we started tonight as well. For those people who have gotten the virus and have recovered from COVID, do they need to get the vaccination, and would you recommend it? And if so, why would you recommend it?
I looked into the latest on this. About 2 or 3 weeks ago, I would have said, we don't really know yet. We don't have enough data. We would be looking for people in the hospital that are sick, and then we would find out, did they have a previous infection, or did they get a vaccine, right? Well, we know already that the vaccinated people are far, far less likely to be hospitalized. That, I think people just know that. But the question you're asking is a very interesting one. Like, is natural immunity that you get from the virus itself is good, or could it even be better than getting the vaccine, right? Ignoring the fact that you take a great risk of, getting pretty sick if you get the natural infection. So just assuming that you're not going to get really sick, is it worth, relying on that immunity to be protected in the future? That the CDC is recommending a vaccine after a period of weeks after infection. They're recommending a vaccine, and the reason they're recommending it has been, supported by data recently. So there was an mortality and morbidity weekly report study that came out from Kentucky. This was August 6th, so this wasn't that long ago. People previously infected with SARS showed that unvaccinated individuals are more than twice as likely to be reinfected with COVID-19 than those who were fully vaccinated after initially contracting the virus. So that means that if you're unvaccinated and you were previously infected, you have 2.34 times the odds of reinfection compared with those who are fully vaccinated. It's about twice the amount, greater chance of, getting sick if you rely on the natural immunity. So yes, your immune system is designed to fight off disease that you've previously been exposed to, and that does work. You do create immunity, but the vaccine immunity is better. That's the bottom line of that study. And it does fit with what we know from just general knowledge of other experiences of other vaccines and other viruses, that a lot of times what a virus will do is manipulate the immune system to sort of down regulate the immune response, right? They have genes that can do that. Viruses have either dozens or hundreds of genes and they can actually modify the immune system to cause less of an immune response, whereas a vaccine is specifically designed to amplify the immune response so that you get a robust antibody response. In fact, some vaccines that you might use in other species besides humans may cause quite a bit more inflammation, but they're much more effective. And we deem that that's okay for a cow to have like a sore arm, but not so much for a human to have a sore arm, as many, so they try to come up with vaccines that don't have as high of a side effect, but those side effects usually just mean the vaccine is working.
I got a good one here for you. And this is pretty specific. And so let's listen to this one. Family history of autoimmune issues, and heard the mRNA vaccines can cause them to come out of dormancy. Have you heard about the Novavax, which seems to be more of a traditional vaccine? And would you recommend that perhaps so that somebody can get a vaccination, but not necessarily do the mRNA vaccination? And maybe that's true is that Johnson & Johnson as well, along with Novavax, or both those?
Yeah, no, the J&J is an adenovirus-based vaccine. So adenovirus is a virus that is replication defective. It can't replicate in your body, but it can deliver the and express the genes that you put in there to, the spike protein. So adenovirus vaccine is different than the Novavax. Novavax are they're just it's a collection of proteins in a particle form that just gets delivered. And I don't think Novavax is yet approved, but it might be a great option for people that have literally any concern about nucleic acids, because it's another platform that it's merely putting in a immunogenic molecule or collection of molecules into your arm. So on the other hand, the question regarding autoimmunity, autoimmune disorders, autoimmune disease is quite common in the population, and it's sort of a hyperactive immune system in a way that's directing immunity to your own tissues. There's thyroiditis for Hashimoto's, for thyroid. There's, of course, autoimmunity that can cause you to attack your pancreas and you get diabetes, these kind of things, or just basically inflammation. So that is a case where you need to consult your specialist doctor for the best medical advice. Scientifically, I can't think of a particular reason why the spike protein would trigger autoimmunity per se. I can't think of a reason why. On the other hand, having a COVID infection could be a very bad day for anyone, including someone with autoimmunity. So I would suggest that the vaccine would be safer than getting COVID. That's just some non-doctor medicine advice that I would say. I'm just saying what I think. I'm not giving any medical advice. I would definitely encourage them to talk to a doctor. Yeah.
And for specific cases like that, absolutely, doctor's the first stop. Absolutely.
Yep.
Let's see. Here's a relatively easy one, I think, Dr. Story. So there's been talk about booster shots for those people who have gotten a vaccination more than 6 months ago. Is that something that you think will be required for everyone who's been vaccinated? I think specifically Pfizer probably is what people are thinking about here.
Dr. Keller, I just did a dumb thing. I looked at the chat and it said the sound had stopped. And I don't believe that's the case. I hope that's someone else's. Could you just say your question again? I'm just so dumb. I was reading and I just I'm not good at webinars. I'm really bad at webinars.
You're really terrible at this. So
yes. Sorry.
The question was about boosters. Do you think the boosters are going to be required for everybody?
Oh yeah,
I think that refers to the Pfizer 6-month booster that we're looking at right now.
Boosters, good question. Boosters are a thing with vaccines, right? Why do you need a booster for any vaccine, like chickenpox vaccine? You need a booster. You need 2 boosters, I think. It's because the vaccines, every time your immune system experiences the vaccine, you get better immunity. The cells that are produced the first time live on in your body, as you probably know, as memory cells, memory B and T cells. And then when you wait a period of time and re-stimulate the immune system again, clones or derived cells from those original cells reactivate more quickly. They start producing antibodies again. T cells start doing their thing again. And the actual antibody gets better. The DNA gets mutated and selection occurs and you get better antibodies. So there's two reasons why boosting might be helpful in the case of the current pandemic. One is I'm not sure, but I suspect that in the future they may boost using variant or a mixture of various variants that are out there in the vaccine. There's no reason you couldn't put in more than one. I think it'll be interesting to follow the science of how they do those studies, because I don't know if they need to, make a brand new vaccine, if they need to do the entire 40,000 person study, or if they can do a smaller study for safety and just monitor. So I don't know, that'll be interesting to see. But even boosting with the current vaccine is likely to just improve the immunity overall, just to make the immunity better. And it's unfortunate, I think, that we can't have more vaccine all around the world. Here we are getting our booster, whereas some countries have 1 or 2% of the population vaccinated. So I really think they should really focus on vaccinating the world with at least equal intensity to getting ourselves booster shots.
Yeah. This is a pandemic. It's global, and we need to have the entire global population.
Will I get one if it's available? Yeah, I will. I mean, for sure.
How about this? Why is the J&J vaccine less effective than the Pfizer or Moderna vaccine in warding off COVID-19?
Yeah, that's interesting. No one knows the detailed answer. It is just you do the study and you look and you see what is the effectiveness. So the study is done. You have vaccinated people and you have non-vaccinated people in the study with a placebo vaccine or another vaccine. And then you wait a period of time until in that group of 20 or 40,000 people, there are like 200 people that got sick with COVID, right? And then you don't know whether they're vaccinated or unvaccinated. Then what you do is you unseal the envelopes, you take a look and you say, oh, wow, like 95% of the people that got sick were the ones that got the placebo. It works, hooray. Mm-hmm. And every vaccine is different. Like every single vaccine is different and has different levels of effectiveness. In fact, the flu vaccine sometimes is low as 40%, 50, like not super effective, but it's still given out because that prevents a lot of sickness, a lot of illness. And in fact, they were hoping that they would get a vaccine that was, at least 60, maybe dreaming 75% effective, right? Mm-hmm. Oh my, even 40%, we probably would have used it. And the thing was in the 90s, at least with the Alpha. Now with the Delta, we see that the variants tend to escape a bit. Not only do they escape some of the antibodies to the spike protein that you made originally, the spike protein is mutated and those antibodies don't bind as well or even at all. And so it's not as effective at neutralizing the virus. One reason why it can escape or break through. The other reason is you may just not have responded well. Certain fraction of the population always will not respond well. This is why it's 95%, not 100% effective.
And linking these 2 points here about effectiveness and also about the booster, you sort of hinted at this, but just to clarify, will the booster give higher immunity or just the same level of immunity for a longer time?
I would say both. I mean, no, higher immunity for a longer time. It's just you're creating more cells, more clones that have better antibody binding and better T cell receptor binding. So the antibodies in particular, they improve, they get better. So the fact that and you're going to have more cells presumably set aside. So yeah, booster shots are just a normal, very well studied phenomenon of the immune system. So like when you get re-exposed, your immunity goes up. And this is why when we have the flu, sometime in our life, we get exposed maybe, and we didn't really feel sick. We're just continually exposed yearly, probably, and it continually boosts our immunity. And now and then a new flu comes along that is new enough that we really get sick and we get a bad influenza. Flu is much more, at least was much more well studied than coronavirus. Now I don't know. Coronavirus is catching up very quickly, but so much is known about the flu. Very different kind of virus, very whole different family of viruses, and usually that comes, again, similarly to coronavirus, we believe comes from the animal world and jumps into humans, and unfortunately makes us sick. And people expected a pandemic. People. I mean, yeah. I did. I read the Coming Plague, Lori Garrett, I believe, back in the 90s. She wrote this thick book about, we're sitting ducks. We got to be ready for a pandemic because it's going to happen. It's happened multiple times in history. It keeps happening. But we didn't expect it to be coronavirus, although we could have. I mean, some people probably thought it could be because of the MERS and the SARS-1 and MERS, which are two other ones that are, in fact, cause more severe illness, and therefore don't spread as well. So ironically, those diseases, have a much higher lethality rate, and therefore didn't get a chance to just spread around the world and make 1% of the population really, really sick.
Right, right. I got a question here. I'm going to actually combine two questions. They're both talking about long-term effects, and one viewer is asking about long-term effects of the vaccine. Another is asking about long-term effects of COVID, the long COVID that we hear about in terms of symptoms that just persist. And just your perspective on how long the long COVID symptoms we can expect to last. Do we have any idea? And related to that, with the vaccine, is there any indication that there will be any effects long-term? And maybe we can look at some of the other vaccines that we've been taking and apply those if we've seen any long-term effects from the vaccination. So I'll let you choose which direction you go first, vaccination or infection.
All right, well, so the question has to do with long-term effects. So effects that last, say, more than a year or maybe months and months. And what was surprising is with coronavirus, I'll talk about the disease first. Like, what was surprising is that this idea of long COVID, I mean, that started to crop up as a thing, a few months back, maybe 6 months ago. People were seeing, wow, people are just sick, and this is not good. They've got brain fog. They can't function. They lost their sense of smell. I mean, that was another whole very interesting symptom of this particular coronavirus. It must target some support cells of your smelling system. Very strange. So these symptoms persisted, the lack of smell for months or weeks and weeks, and the brain fog and so on. And now we're starting to wonder if maybe these mysterious illnesses that people have been getting, like chronic fatigue syndrome and things, could just be this kind of related to this kind of a viral infection that someone got and it just lingers around. Questions that remain to be answered, like, will the vaccine, what does a vaccine affect in a positive way? Does it help with the long COVID symptoms? Maybe there's a persistent viremia in the body causing this. So that's we know the long-term effects of the virus for many people is bad. And also the surprise was that it's something like a third of the people that are infected tend to have some lingering effect. I read that's a lot of people. That's a huge number of people that are affected. Whereas with the vaccine, I don't think that there are any reported like really long-term negative effects other than you're making B and T cells that linger in your body. I mean, you could come up with a scenario. This is what people are doing, I think, to scare people about the vaccine. They're saying, your body just might make some autoimmune antibodies that are going to, either enhance the infection cycle. That's been checked. It's been looked into. Theoretically could happen, but so far they haven't seen it. You're going to make some auto antibodies. These cells linger in your body, and it's very scary. You got to watch them. But these are the cells that are protecting you from COVID. So you can sort of twist the things that are going on long term from the vaccine rather, to make it sound scary. But they're looking very closely at the side effects. People say, oh, the vaccine has caused deaths. Just look at the VAERS system, the vaccine adverse effects reporting system, you'll see like people that were vaccinated and then they died the same day, like right away, they died after they were vaccinated. Well, when you a lot of people made a peanut butter and jelly sandwich right after they were vaccinated. So there are things that happen at the same time. The key there is to look and see if there's any causative correlation between the kind of, the condition the person was in, like what was it, was there any connection? And they look very, very closely at that. And, they haven't seen any causative connection, only correlative connections. That's a really important point.
That's the point of these huge studies, isn't it? To try to find the causative agent of those side effects or of death.
Yeah.
I mean, anecdotal data is not helpful. It really isn't,
And it can be.
It could be anything.
You can be like, you want that VAERS system because what if like in a certain part of the country, you start seeing a lot of something, that's very surprising or very unusual. And then you can say, wow, look at these lot of a vaccine was, bad. In fact, there was a lot that was contaminated. Oh, contaminated. Well, I guess it had little pieces of metal in there or something like that. I mean, I don't know how that happened, but they caught it and they're working on that. Now, would that have caused anyone to get sick? Probably not. I mean, I got a little piece of metal in my thumb the other day, I'm just saying. So they look very closely at, at these vaccine adverse effects. They're reported, but people worry about that and think they make a wrong connection saying that the vaccine caused the death when it's just a correlation in time. I mean, it's hard. The same kind of thing happens with autism and vaccines, that kids get autism right around the same, or they display symptoms of autism right around the same time they get their vaccines. And then people just make that connection. And study after study has shown like no causative connection between the two. So
I think what's troubling here, I see a few comments here about long-term effects, and we hear about stories of brain fog that persists, that implies some neurological long-term effect. Lung damage. I had a student who shared with me the other day that he had COVID 6 months ago and still has not regained his endurance, can't take deep breaths. So we know lung damage. I see a comment there. Lung issues are a major concern.
And the vaccine doesn't do any of those things,
Right.
Doesn't do any of those things. I think it's like, I find it, understandable why people are hesitant to take the vaccine, because it's something unfamiliar, it's mysterious. But I feel like if they know how it works, if they know and really appreciate the risk that not getting vaccinated poses to them, it's a much more there's a much greater chance they're going to suffer bad consequences from not getting the vaccine, right? And that they need to run those numbers and think about it. I think it's pretty clear to me, at least, that it seems like a no-brainer. But I understand this scary stuff I've seen, like literally wrong information. That's like sounds really scary. But I, as a biologist, know, well, that's just not right. That doesn't make sense, But you wouldn't know as a reader of just these rumors are flying around. So.
You mentioned the spike protein a few times. That is some you've discussed already. But a question here: do we know if there's any damage to the body from the spike protein itself that would be created from the vaccination? And along with that, something like myocarditis, does that maybe have anything to do with the protein damage to the heart from the spike protein, or is that unrelated? Is that an issue you've heard about?
That's a good question. I believe this spike protein is highly unlikely to itself, somehow cause some kind of an effect in the body other than activating B and T cells to respond against it. So they're going to, this protein is going to get brought into the cell, chewed up, chopped up, and destroyed within a pretty short time. It doesn't linger in the body and just go around wreaking havoc and doing damage. You got to keep in mind that the vaccine RNA is going to be broken down and gotten rid of fairly quickly in probably days. And same with the protein, it's going to be gone. So, and the spike protein, if you think about what is its job is to provide the attachment site for the virus to enter the cells that it targets. So all viruses have some protein on their surface, which is their sort of their suction cup to like get on the cell and then bind and get into the cell. And so that's its job. It doesn't have a job that I don't think anyone thinks that it has any other real fancy job, especially like attacking the heart or doing something like that. It doesn't seem plausible to me. It doesn't have like, I don't believe it has like enzymatic functions, things like this. Yeah, so they've created the spike protein, and they've engineered the spike protein to be a particular folded version that is the correct one that you want to make antibodies against. So it's a very smartly designed vaccine that they designed. And so I don't know, did I answer that? I mean, so yes, these also, by the way, these symptoms that they're finding, these potential associations with maybe the J&J, some of these adenovirus vaccines, I don't know, maybe this is just a very rare, I mean, really rare side effect of the adenovirus platform itself, or I don't know. I don't think they know exactly what the mechanism is, but they're looking very closely at all those things, right, to make them as safe as possible. Yeah.
I have a question, actually 2 questions about disinfectant sprays. Are they effective, as you know, in terms of reducing infections, and how long until the virus might be killed with disinfectant sprays?
Yeah. So the best kind of thing would be the hand sanitizer, or some kind of a 70% ethanol spray is really effective, and it's almost instantaneously destroys the virus upon contact. Interestingly, when they look at transmission events, this is a big change from early in the pandemic. Early on, like you mentioned earlier, I was worried about my mail. I was worried about the groceries, touching things, the little things to open the door, push the button in the elevator. And what they've been seeing is that very, very few cases as a percentage, I mean, probably some, but very few as a percentage are from contact. It doesn't mean we shouldn't use hand sanitizer. It doesn't mean we shouldn't, if you wipe your nose and then shake somebody's hand, I mean, that's a possible mode of transmission. But just getting it from surfaces around seems much less of a way of this particular virus spreading than. What do you think? What is it how does it spread? You all should know by now. It's aerosolized droplets, which, by the way, my computer screen is covered with. If you turn down your screen, it's kind of gross, but you can see all the drops that fly out of your mouth every time you talk. I mean, lots of them, so these little droplets, they dry up, they fly around the room, and they linger in the air unless you have air exchanges. So this is why schools and businesses are working on air exchanges. That's a really important way of combating the virus. People have developed filtration systems with fans and filters in the room, HEPA filters or homemade filters. But the best way to lower the spread is by just catching those droplets with even the most poorly constructed amateurish mask in front of your face while you're talking is going to catch a lot of those little droplets, and you got to get, a lot of people want to hear them anti-masking talk. They make it sound as though, well, it's okay, you just wear your mask, I'm not going to wear my mask. But the problem is they're producing the stuff, right? And my mask is not a tight sealing mask, so they're going to infect me. So when you wear a mask, think of it, it's like you're blocking your production of potentially virus, because you don't know if you're spreading or not. You can't tell. A lot of people are asymptomatic, even with the Delta. And the Delta, unfortunately, has much higher, like 10,000 times greater levels of virus. So, and it spreads among the vaccinated. Vaccinated people can spread it. So whenever I'm indoors, I wear my mask all the time. And I get annoyed if I see a store that I go in and no one working there has a mask on. I'm worried because, they're potentially filling the air with little tiny droplets full of virus. So I either leave or I go and get my KN95 tight fitting mask and go in the store, so that's what I do as a biologist. Yeah.
You brought up 2 things I want to go back to. And in terms of mask effectiveness, it really is a kindness to wear a mask to protect other people, but is there a protection that I would get by wearing my own mask, given that I am still sucking in air through the side of the mask and perhaps through the front as well?
Yeah.
There's still some level of protection. Is that true?
Well, that's an interesting question. I kind of think it's not a great amount of protection. I really do, because think of the volume of air that goes in your lungs compared to the volume behind that mask.
Yeah.
A lot of the air is coming around the side. So again, those droplets are very, very tiny and are fully capable of getting around the mask. So this is where there's so much confusion among people about masks, because they're like, that thing doesn't work. It's loose. Look at, right? So you got to think of the mask as catching the stuff, not so much filtering it in. And if you push it against your face a little bit, say you're someone's a close talker, just put that thing, just push it on a little tighter, then you're probably getting better protection. But I wear mine a little bit loose when I'm teaching, because it's a production. I'm trying to block the production. Mm-hmm. And everyone in the room, all my students, yeah, go ahead. All my students are wearing masks, which I'm thankful for. I'm really, really thankful. And I would feel far less comfortable in the room with half the students wearing masks. I would not enjoy that. I would have to probably wear my KN95,
Yeah. And I think that is a kindness that they're doing for each other. And I think we sort of lost that view of us as Christians protecting each other, protect our neighbors. And so I think that is helpful to hear. The other thing that I want to get back to, you mentioned, the disinfectant spray, and how like early on in this pandemic, we were spraying everything. If somebody knocked on my door, I would talk to them, close the door, wipe it down, else. And we don't do that anymore, but it highlights something that I think causes some hesitation with the vaccine, or maybe hesitation with trusting the voices here that we're hearing about the science. And that is, I think many people might view science as static, and maybe we've changed our message. Does that mean we don't know anything? Does that mean that we're not trustworthy? But maybe you could just talk about that a little bit, that the evolution of the science here is super important. And as scientists, we go with the best science that we have right now. And that has changed over time. Would you agree with that?
Yeah. So why did the NIH promote wiping everything down and not even wear masks originally, like back in maybe February or when was this? March, February. We weren't wearing masks. I was on a trip down to Florida with students over spring break, and by golly, I brought hand sanitizer on that trip. I had been reading, and I knew about this thing coming from China, and I was concerned. I said, this could very well be a pandemic. And the current thinking at the time was, you got to spray the surfaces, watch for surfaces, because that is a very common mode of a lot of viruses spreading. It just so happens that we didn't have data at that time. We didn't have the real robust data showing how this particular virus spread. So that was an assumption that we made based on the best of thoughts, best of intentions. And it turned out to be really not correct, right? But that's how science is. You have to look at the data supporting any particular claim in science. And there's always a degree of uncertainty in any study that's done. There's a level of uncertainty. Nothing's ever proven in science. You look at the weight of the evidence. And at the time, the weight of the evidence was just like, well, from other viruses, the weight of the evidence was we should definitely spray down everything, wipe our hands. And I mean, if you're watching closely, I probably wiped my nose. I went like this a few minutes ago. Like, we're always touching our face, and there's like, don't touch your face, right? Remember that? I mean, it's still true. You can potentially spread it by touching your face and then shaking somebody's hands. I do the elbow bump all the time now. Elbow bump. I'm just, shaking hands, not a good thing during the pandemic.
I wonder if that'll come back. I wonder if we'll ever get back with shaking hands.
It might, but with a little, So it may take a few years for us to get back. I think still. So people say, that Anthony Fauci, he was wrong. He didn't know what he was talking about. He did know what he was talking about at the time. He had the best data of the time. But guess what? He changed when the data came in to make an updated statement that is fitting with the current level of data and understanding. So I had seen a few papers that were put out, not papers, it was a news kind of reports that had come out about certain restaurants and where people were sitting and who got infected in this particular super spreader event and among families. And I started to think, and this is back in like February, pretty early on, March, I started to think, wow, it does look like it's going through the air. And sure enough, very soon after that, that started to be well understood and established, right? Mm-hmm. So not every scientific story, if you will, is firmly based on evidence as every other. So as a consumer of science news, always look at the weight of the evidence, like a 40,000 person safety study that's done with explicit ways to avoid biases and things is a good study, and you can have confidence in the result as a result. So a small study saying, avoid this or that thing in your diet is just not weighty. Still makes the news, but you got to ignore
something
that.
like that. A question, and I have a giant topic for us to shift to momentarily, but just to sort of put a cap on that, there's been a suggestion treatment with HQC and also ivermectin as an effective alternative, and there's just no data. To talk about 40,000 people in a study to look at the vaccination compared to no data really at all. How do you view those? Those alternative medications that people might be tempted to take because they're worried about the vaccination.
So in the early days, one of the ways of helping someone would have been to just kind of modulate your immune response, because you can get too much of an immune response. It makes you very, very sick. And so that was part of the idea behind the hydroxychloroquine, because that helps to downregulate the immunity and over responsiveness. But it certainly is not a specific antiviral that targets the coronavirus. There's no universe in which that is even remotely possible. All right, people. So all you can hope for is maybe that it's going to somehow help modulate your immunity. Well, but now we have actual drugs they can give a severely ill person that can block the virus. And so if you're acutely infected, they can give you the antibody preparations, the monoclonal antibody drugs that can block the replication cycle. I'm not sure how effective it is late on when you're really sick, but if you catch it early enough, it can block the early replication cycle. So those, you want a drug that is mechanistically targeting the mechanism of this virus. And it's very unlikely that a medicine that's an anti-worm medicine, like they use ivermectin as an anti-filarial medicine, anti-worm medicine, is going to have any kind of beneficial antiviral effect. And they can test it in vitro and so on. They can test it in mice. They can test it in different ways. And I mean, what's the motivation for people taking that? I mean, why would they? I cannot understand why they would do that.
Proposed by a doctor who has maybe some other ideas, some hesitancy with the vaccination, and this might be something that you could take without the vaccination if that's a concern that you have. You can always
find one or two professional people or Nobel Peace Prize winners or even doctors. You can even find, just one or two, somewhere in the world, you'll find a doctor that will say something that's just really out there that's not supported by science. And in this case, if you really don't want to take the vaccine, if you really want to prove or convince yourself it's not safe, you're going to latch onto every word that person says, even though it doesn't fit the data. It's not good science. It's not well supported. There are other things you're not listening to. You're getting sidetracked, right? And some of the stuff is very well slickly produced and looks good, but I just see no evidence that those compounds have any real benefit. I mean, of course they're going to look at it. They're going to look and see. And if you had something, that would be awesome. That'd be great. There's no reason why, if there was an effect, it wouldn't be published in a top science journal and you'd be a hero, right? You'd be a real hero.
Absolutely.
But the real hero are the people that developed mRNA vaccines, right? I mean, So here, let me just share my screen for 1 second. So you guys are getting tired of looking
This
at
is
it.
exciting.
So
A
so
screen share, no less.
yeah, this is a spike.
Webinar.
This is a spike
Oh, look at
protein.
that.
Look at that beauty. Look at that spike protein. It's a trimer. That's where we're making antibodies against. And I here we go. So this woman, I don't know if I should even try pronouncing her name because she's Hungarian. I don't know how to interpret Wikipedia's, but we'll just call her Katalin Carico, something like that. But she had the idea that this RNA vaccine could be made. Like, she was studying mRNA. She was studying ways of, she'd noticed that certain kinds of RNA can be made to be, more acceptable to the body and so on. So she'd done this RNA research and said, we should try this, make this as a vaccine. So she joined the Drew Weissman lab, and they started working on this back in 2005. All right. So this is a while ago. And then when the pandemic hit, they said they partnered with BioNTech, which is partnered with Pfizer. And so this is the story that you really should all learn about this woman. She championed this kind of vaccine when I think biologists like me, kind of thought that wouldn't work. We thought, well, mRNA is such a temporary, such a fragile molecule. It doesn't linger around. It's how are you going to get that into cells, right? How are you going to do that? So there's a lot of reasons why you think it might not work, but she's like, no, it's going to work. It's going to work. And sure enough, it worked.
So I wonder, Craig, has this technology been used for other things other than the current vaccinations, current vaccines, I should say?
Yeah. So there are, delivering proteins into the body could be, a therapeutic, used for therapy for various things. So right now, I think, I think I read in that Wikipedia article, and, Wikipedia for science, you guys, is pretty good because there's lists of sources, papers and things in there. So you can look at the original articles. But yes, they are using mRNAs for other things, not just vaccines.
And just to put a cap on this one, on the ivermectin and the HCQ.
Hydroxychloroquine.
Yeah, a few people have said that they found articles, they found information about it. Is that trustworthy sources in your mind? Is it still in infancy and we should not put too much stock in it right now? Just to finish that point.
Yeah, that is an interesting question because there are some journals that are better than others. There are some journals that are open source or open source journals where they get reviewed, but the weight of the evidence may not be as good. If it were something that were truly revolutionary and extremely effective, it would probably be in a much more like well-known or reputable journal like Science, Nature, Immunology, or one of these kind of journals. So there is a paper out there that talks about this antibody enhancement of infection, which is actually in a decent journal. It's a good paper, but it's sort of speculating something that might happen. And it's worth looking at as a potential thing to worry about. But right now, there's no evidence that it is happening. They take a particular clone of an antibody and look at it from a very biochemical point of view and see how it can maybe help the virus infect. But I don't think there's any evidence that that's happening in real life, if you will, in actual people. So you really do need to really weigh these papers very carefully.
Look at where they're published.
Yeah, where they're published. And also, ask your scientist friends. Ask your scientist friends about it. Like me, ask me about it. Send me an email. I'm on email. So craig.story@gordon.edu, and I'm happy to look into it further.
So I like just to check, make sure you're doing all right there, Craig. It's 7:53 or so. You're all right? Do you want to keep going a bit longer?
I love talking about this stuff. This is what I do. I do.
Of course you do.
Yeah,
if I know anything about you, it's that you love to talk about science. So this is great. So I mean, maybe we can go another 30 minutes or so. I'd like to finish by 8:30, but I still have several questions I want to get to.
Wow.
And so I said that I've got a big topic, and that involves reproduction. And so I've seen a few questions about reproduction, and I think we can approach this both from COVID infection and also from vaccination.
Oh, yeah.
I've seen a question here posed about potential miscarriages, a question about breastfeeding and wanting to have more children, and the concern with the vaccination, and also just general questions about reproduction. And I think we can look at that, in a variety of ways. People who want to have children, people who are concerned about abilities, in reproduction. And so just what you've heard both about the vaccination, but also about COVID and its impact on reproduction.
One thing I know has been shown is that I believe that women that are pregnant are more likely to get more severe COVID symptoms. I think that's been out for months.
Yeah.
On the other hand, the vaccine works just as well in a woman who's about to become pregnant or who is pregnant. It works just as well in them and still does the same kind of antibodies production, immune cell production. My own research for my PhD research was involved the mechanism of antibody transport across the placenta, which is truly amazing. You should all learn about this. This is really good stuff. So the placenta is the barrier between the mother and the fetal blood circulations. They don't actually mix, but the maternal blood bathes the fetal capillaries in the placenta. And at the interface between the placenta, between those different blood circulations, there's a receptor that grabs onto the antibodies of the mother and brings them across and drops them into the fetus's bloodstream. A very particular protein whose job is to do that, called FcRn. That's my gene, you guys. So anyway, I don't want to brag, but anyway, so it does that important job. So think about this. So if you get vaccinated before pregnancy, then those antibodies that you are making, right, your body is going to deliver those to the fetus before birth. Like it's going to deliver COVID immunity, like antibodies against COVID, so that when that baby is breathing air and potentially breathing in tiny droplets with virus, it already has your antibodies in its circulation. I mean, that's wonderful. That's great. So it's very important for pregnant women to get vaccinated. In contrast, not getting vaccinated, you might get sick. You might get, that would be extremely bad for the fetus, for you to be having those fevers and all that kind of stuff. So I don't believe there's any reason why, to think that the vaccine would be somehow harmful to the fetus. That is just file that under the false rumor department. I think there's no evidence for that. There's no evidence.
Any evidence at all about that.
So that's the question. Yeah. What's the evidence?
There was a question anecdotally that there was one of our viewers says there was a report of a woman who got the vaccination. She was pregnant, and then she and the baby both died. And the question actually is a good one. It says, was that anecdotal? Is there any scientific evidence of that? So a really well worded question, I think. They're looking more at, again, those anecdotal points versus the more widespread question.
Yeah, I mean, that is a very sad story indeed. I mean,
it's incredibly sad.
But if it was the case that there was a connection between the death and the vaccine, then you would see a lot of it. You'd see statistically, you can look and see like how many people die every day, how many pregnant women die every day. And then you say, has it gone up in the population that have received a vaccine? So you just have to run those numbers. And again, science does not prove things. It just helps you have a degree of statistical confidence that, well, this looks like it's not going to fall in, not going to be connected causally. So bridges collapse all the time, right? But I know that for the last 5 years, this bridge hasn't collapsed. It's probably not going to collapse today, right? So you have to kind of go on the best data and the best evidence. And I don't think there's any evidence that there's a causative connection. So those stories spread like wildfire, but be aware of those like individual stories. When you have a country of 300 and whatever million people, you're going to have a lot of those little anecdotal stories, right? You're going to have many of them. And with the connectivity of the internet, YouTube, and so on, those stories can go around like wildfire. They go viral, if you will. And oh, that's a bad term maybe, but they spread like the coronavirus. And unfortunately, that doesn't mean that there's a real basis for them.
Mm-hmm.
To
And in
cause.
contrast, this long COVID that we've been talking a little bit about, there are reports of some pretty negative consequences for both men and women reproductively. So a real concern there.
Yeah, there's something about sterility in men or impotence and stuff like this. Like there's some very probably little talked about downsides. People like to focus on the downsides of the vaccine, which I don't think they're real, but they don't talk about the downside of coronavirus. Why is that, Dr. Keller? I don't get that. I mean,
I don't either.
I talk about the downside of the virus. I dwell on it.
We know people who've gotten it. We know people who've gotten it both before the vaccination and
sickest I've ever been.
We have some friends who got breakthrough cases, but thankfully they got the sniffles and lost their sense of smell for a short time. And I'm so thankful that it wasn't hospitalization or anything like that. So a few questions here regarding, let's see, where did they go? I was listening too intently to you, Dr. Story, and I lost my place here.
Yeah, I did that earlier. I mean, we're not really professional webinar people, are we? The audience is, I'm sure they understand.
I think there are two questions here that I think the two of us can both answer. And it really is, why push for the vaccine when people who get it are protected? What about freedom of choice? And then related to that.
Well, we talked about that already, right? We already talked about the first one.
Yes, right.
The natural immunity is about twice, less protection or something on that order.
Right. And I think the question I want to get at here, though, is more about why does this feel like it's being pushed on us? So let me stress that this is not a scientific question. This is more a question about why does it feel like the government is pushing this on us, and why does it feel like it's being developed by the big pharmaceutical companies who are out to make money. And I would say, I mean, there are lots of reasons this is being pushed. It's effective and it works, and we want everyone to be protected. I think we're all tired of seeing the stories of death and the stories of illness. And so personally, I mean, yes, I understand that we don't like anybody telling us what to do. I mean, that's, even though we do those things, we wear seatbelts and such, but we don't want that to be true for anybody, for anything. But importantly, if we just look at the science, there's great reason to do this. And so it does bother me when I see lotteries to encourage people to get the vaccination because it cheapens it, I think. Instead, there are enormous reasons to get it. And as Dr. Story's been talking about, I wonder if you have any perspective there. I don't want to spend much time on this because we said we focus on the science, and this feels a bit political to me, and I don't want us to go down that path. But
I think I mean, it all falls under the umbrella of public health policy and public health. So maybe we're just not used to the concept of bad diseases because we're generally shielded from that in our society today. So if you were around in the 50s, people were getting paralyzed and couldn't breathe because of polio. And so first of all, the symptoms were right there for everybody to see, and it was spreading. And, polio was a horrible scourge, right? I mean, spread through the water, affecting the gut and affecting the nervous system and making you potentially paralyzed. And like, whooping cough, measles, mumps, all these diseases, right, that we just don't see. A lot of doctors haven't even seen, some of these diseases. And so I think we just got kind of comfortable with, everything's good. We don't have to worry about disease. We're great. And then our bubble is burst by this coronavirus. And now we're back where people are dying. Our friends are dying. Our loved ones are getting sick. And yeah, it's a small fraction of 100%. It's a small fraction, but when you have millions of people in the country, it adds up. It adds up. And the hospitals fill up, and then you can't go for your scheduled surgery because the hospital's full. and doctors and nurses, they're under incredible stress. So I think we just got comfortable, and we're not used to the idea of public health policy and public health.
Yeah.
Public health is really no different than a seatbelt law, or and maybe some listeners don't like the seatbelt law. I mean, at first, when it was put out there, we had to wear seatbelts. I'm not wearing a seatbelt. I want to be thrown free. I want to be thrown free from the accident. Well, that's a mythology. No one who's thrown free is usually in pretty good shape afterwards. So these are things that the government, institutes for the greater good of society, which you can't argue that seatbelts are not a benefit for society, and individually a benefit as well. I feel safe with my seatbelt, and I feel naked without it now, right? We've all gotten used to that. So I would hope in the future that we would take it as a cautionary tale that we've been a little bit too complacent and overconfident in our body's ability to fight off disease. Not all diseases our body can easily fight off. At least not everybody can. And we have the tools that are developed, which are these vaccines, which work really, really well, all the way from smallpox to polio. Sabin and Salk were heroes, and everybody ran up and lined up to get that vaccine. I'm sure there were a few who didn't, but look, polio is eradicated except for a few countries around the world, right? It's gone. Smallpox is gone. So they have great potential for saving many, many lives. And I just feel like it's really sad as a scientist to see people that just don't understand how they work, and they're worried and they're concerned unnecessarily, in my opinion.
And I think it is, again, you and I talked earlier that there is a healthy skepticism. That is really important. But it's, we need to look at data, we need to look at information and look at good sources. And I think that's where, but also understand that sometimes we're given data that's been manipulated a bit, where we emphasize, the either anecdotally the number of people who died who have had the vaccination, or not fully presenting the full picture, especially as we break out the vaccination per age group, which is such a critical difference that, if a study doesn't present age group, the study is not very well done, frankly. Here's one, Dr. Story. It's a good one. They're all good. But just a question that also came to my mind that you and I talked about earlier before we met tonight, and that is that vaccines, we know, smallpox, polio took years and years and years to develop. We know the warp speed that the previous administration really pushed, Donald Trump's administration. And suddenly we had the vaccination within just a few months, and it felt rushed. Could we trust it, given that it feels so rushed? And could you just respond to that time and why it happened so fast? I think that's really a fascinating story.
Yeah, like I alluded to this a little bit earlier when I mentioned that the mRNA platform had been studied since the early 2000s. And so a lot of the tools were being worked on. In fact, for many years, even before that time, people were trying to make a DNA vaccine where, like, you would take a DNA gene and put it into the muscle, and then the muscle cell would produce protein from that gene. Now, that would raise the specter that a lot of people worried about. Putting DNA in there, that could potentially, and so that was the thing people were really, really working on when along came our hero, and we started working on mRNA vaccines. So a lot of the work was ready. It's not the same time as in the past where we have a much more advanced tools for studying immunity and studying the immune system now. So we can do studies very much more quickly and effectively and see what's happening to the immune system. So the development of vaccine is pretty quick with these adenovirus vaccines as well, like the J&J vaccine and some of the others. I think there were something like 40 different vaccines in clinical trials back in November, 40 different ones, lots of different platforms. And so we have a pretty well-developed vaccine technology base, and the Novavax one may be coming online soon as well. So the technology is fairly well developed. And so just like everything else, like your cell phone, it's better and better, faster and faster, and sometimes cheaper and cheaper. as time goes on. It's just the progression of technology. And so should we really be surprised that some, biology thing is, faster, cheaper, and easier to make today? I mean, I don't think so. I mean, I'm not surprised. I can make a little COVID test in my own lab very easily. It's the tools are there, and it's just a different day. And the reason why this came about so quickly is because the government actually spent a ton of money to have multiple projects being funded at the same time, not knowing whether they were going to work or not, multiple trials. And so so by funding things that might not work by the government, then it took away the risk for the company. So a company isn't going to say do 5 different vaccines test all at the same time. What they're going to do is they're going to take the one they think might work the best, try it out. If it works, excellent. Maybe they'll just go with it, right? Or maybe they'll try the second one the next year, and then they'll try the third one the next year. And they won't have the funding to do them all at the same time. So that was part of the, warp speed or lightning speed with BioNTech, I think called it lightning speed. The lickety split studies were done all at the same time. So doing things in parallel is way faster than doing one at a time in order. So that's the other big reason why it was a lot faster. Now, keep in mind that the safety study was not rushed. It just, you have to wait for the result to come in. And so there was no time when they would be done. You have to wait until a certain number of people that's predetermined in the study design is showing symptoms that then gives you enough statistical power to say, yes, this is working or not working, right?
Yeah, absolutely. It makes me wonder, given the amount of money we spent on this as a government, what could be the next one that we solve if we put the same effort towards, solving a major public health crisis? Are there others that we could, put similar amounts of money toward, and it's costly, but they would potentially solve major other virus infection, other things around the world that
I think we've learned something about the need for infrastructure, having enough syringes and bottles and some of the reagents in the vaccine. By the way, you can go on the CDC website and you can actually see the ingredients for the vaccine, every ingredient that's in there. And there was a really good article that I found which highlighted exactly how the vaccine is made. They grow they grow bacteria with the DNA, then they use they reverse transcribe the RNA and they purify that, and then they send that to this other place, and then they get the lipids and combine them. It's really an amazing process that's fully explainable and understandable if you're willing to look into it. And there's rumors that I've heard that they've changed the formula and you're not getting the one that was approved. I think that's highly unlikely, because first of all, you can't do that as a company. Right? You've got this thing approved. That's what you're going to give. You can't go changing that. I mean,
also it works. I mean, why would you change it if it works?
Yeah, I mean, so anyway, those just don't have the ring of truth to me. I'd like to see the actual source of that. Is it some kind of specious source, or is this some who has this information? Like I see, is this ingredient in there? Is that ingredient in there? It's like, go ahead on the CDC site and look it up yourself. I actually did this a week or two ago, and it's the lipids. I was just wondering which lipids are they? And these lipids are very much like your natural lipids. There's one that's a man-made lipid, so you better believe they test that and make sure it doesn't have any untoward effects. But they get cleared by the body, and over time they do their job. They deliver the payload to the cells, and then they just flush out of your body. So I see a lot of people that are worried about what they're putting in their body with the vaccine are the same people that smoke cigarettes, and I'm like, wow, now that is really interesting contrast, right? Because the chemicals in cigarette smoke are known to cause harm. And I mean, I'm sorry for people that are addicted. It's a very harsh addiction. I understand that. But I mean, yeah, it's pretty benign stuff designed to trigger the immune system. No more, no less. And that's what it does.
We put a lot of other things in our bodies we don't know about. And
cheeseburgers and all kinds of stuff.
A question here, and I think I know the answer, about the control group associated with the original studies were eventually given the vaccination. Is that a problem? Does that diminish the quality of the trials? I think the answer here is, of course, they were given the vaccination eventually, because we realized that it was such a good vaccination.
Yeah.
The vaccine was
No.
really good that, of course, they were offered that eventually after we compared, or not we, after the researchers compared, the side effects and the effectiveness and everything else. Of course, they were given that. Thank goodness they were. They should have been.
Yeah. I mean, so no, there's an endpoint of the trial, and they decide this is when the thing is done, and at that point, then they have their results. Then the people can be vaccinated.
So I've gotten a couple of questions about this, and how are we doing on time, Dr. Story? We got about 15 more minutes. I appreciate your patience with us getting questions. We have truly dozens and dozens and dozens of questions here, which is really wonderful. I'm just so thrilled.
I'm glad you're looking at them and not me.
That's really great of people that spend a little bit of time with us tonight.
Thank you.
And it concerns the VAERS report, VAERS report, and that is that many hundreds of thousands of people with adverse reactions after getting the vaccination, 17,000 people permanently disabled. I don't know about that number. Another point, Israel, a study from Israel, 64.5% of hospitalizations are fully immunized. 67% of vaccinated people are seriously ill. And I think we need to talk maybe about data and how we view a place that has such a very, very high vaccination rate, that of course the majority of their people hospitalized will be vaccinated because they have such a high vaccination rate. Is that the way you read those data, Dr. Story, that portion of the data anyway?
Yeah, I mean, they vaccinated pretty much the entire country of Israel. So, and things got really nice and low, and everybody was happy and went out. And then when the Delta came back, people started getting sick again. And yes, vaccinated people do get sick from the Delta variant. Unvaccinated people get much sicker, right? So keep in mind that the protection that you get is variable. That not everybody's it has as much protection, at least for that first and second shot, especially for the first shot. The second shot, hopefully you get more, but even so, not everyone gets the same degree of protection. So those people that maybe got a little less of protection from the vaccine are the more likely of ones to get sick from the Delta. Yeah, the VAERS report, again, I see that as a correlative thing that people are misreading, and they're just saying they're just mining it for information. I think everything is reported there, but there's no. They look for correlations, but it's not the way to actually find legitimate causative connections. I mean, it's there for that purpose, but they being the epidemiologists are looking at that, and they're not finding a causative connection. So just to say someone died from, look at theirs, they got the vaccine and they died, does not mean they died from the vaccine. It doesn't. And thousands of people are going to die every day from aneurysms, heart disease, all kinds of reasons. And millions of people are being vaccinated as well. So those two things together, I believe that to be not a thing to worry about. So the safety studies show that it's safe. And yes, we are monitoring. We're continually monitoring. And now and then we do see something like they did with the Johnson & Johnson. They put it on a pause and they realized, okay, well, it's worth that small amount. So nothing is perfect. It's far better than good. It's excellent. This vaccine is excellent. So I mean, there's so much information out there about how bad the vaccine is that I don't know how you can maybe get beyond that if that's what you're steeped in, if that's what you've been hearing. I mean, it's so loud. They're screaming and they're like, I don't want to take this vaccine. This vaccine is horrible. But I'm telling you, as a biologist, as an immunologist, and this is what your doctor probably would say too, it's a great vaccine. It does what it's supposed to do, and it prevents what is truly horrible, which is the virus.
And I've got a few questions here. So these are just all wonderful questions. Thank you all. These are just really insightful and thoughtful questions we're getting tonight. I've gotten 3 questions about the Delta variant. So the vaccines were based on the original variant primarily. How effective is this in the Delta variant? Do we need to, do we see the same level of safety, or as we compare vaccinated versus unvaccinated with the Delta variant, as far as you know?
Yeah, so the virus has evolved into a form that apparently can replicate more effectively. It can not only replicate in the body more effectively, meaning it produces higher titers or higher numbers of virus particles, but also it makes you sicker because of that very thing. It also makes you sicker, right? Because when the viruses erupt from cells, they break cells and cause inflammation, make you sick. So there's that about the Delta, right? Excuse me. The other thing is it has a slightly variable spike protein. All right, it's changed its spike protein. Maybe part of the reason it can infect better is the spike protein binds, better to the cells and it gets in better. And so you've already responded to the alpha spike protein. You've got your antibodies, and they tend to linger around for quite a while, but they do diminish over time. But you have those memory cells. So what's happening is you're getting exposed. The Delta is starting to replicate in your body. You've been vaccinated, but it's replicating, right? And your immune system is becoming more quickly activated to fight it. And see, some of the antibodies you made will still react to the Delta. Some will not. So that makes your antibody response slightly less effective against the Delta. But you make more than one antibody specificity. You may make 20 or 30 different antibodies that bind to different parts of the spike protein. Maybe not even that many, maybe 5 or 6, who knows? More than one usually. And but you also make T cells. T cells go around looking for infected cells and killing them. And also just activating the immunity in general. So what they respond to is not the spike protein folded in a certain folding, but actually the actual peptide sequences, the little amino acid sequences of the protein that was put in. So your immune system chops the spike protein up and then presents it on the cell surface. T cells see that and they respond. So that whole arm of the response is likely to be reactive against multiple different peptides in that spike protein. And so that response is probably also very robust and potentially could be slightly diminished by a single amino acid change or two, but it's actually more likely to be more robust than the antibody response. So you still have T cell immunity. But why are people getting sick from the Delta? It's because I think it just is a better virus in terms of its own replication ability. And vaccines, this is a kind of a misunderstanding about vaccines. People think, oh, the vaccine didn't work. I got infected. Well, you still do have replication of virus happening when you're vaccinated, when you're exposed in the future. You're exposed by someone at the store, they cough on you or whatever, and you've been vaccinated, you're still going to potentially get that virus in you. It's going to latch onto cells, start replicating. But if you have a high titer of antibody, it may prevent that directly. It may prevent that. But if the antibody titer is not high enough, or maybe it's a slight variant, some of that virus might be able to replicate, and you'll still potentially, especially with the Delta, we're seeing this, you can then spread it on to other people. And so another reason why, a third reason why people might be sort of more sick with the Delta is their dose that they get. If they get a bigger dose, it gives a more rapid ability for the virus to build up those high levels. So that's another argument for masks, by the way. So to lower the dose, even if you're around people, if everyone's wearing a mask, then everyone will get a lower dose and won't get as sick. They might come up positive, but they won't get sick.
Yeah, and I think that goes to a question, another question I received about masks. And so we already talked about masks and their value. The question about a mask mandate, that goes beyond, I think, what we want to talk about tonight, because that clearly is policy. But it sounds like, and your general opinion is that people should be wearing masks while we try to lower the caseload here, because it does limit the amount of infection I might share with others, or maybe some that I might get back from others as well. I don't know if you want to talk all policy or your opinion on schools, or I don't know if we want to go down that path.
Yeah,
right now.
well, yeah. So it's like the seatbelt thing and the role of the government and our complacency with public health policy. So we're just not as trusting of the government in general. Many people are not, and maybe for good reason. But a lot of those public health people, I mean, I know a lot of them worked in labs with these scientists, and it's not like they're like sitting in the lab thinking like, how can we be evil today? No, they're actually concerned about health and the public's health. They're trying to make people be healthy and not die. So if you think of that, put your mind frame around in that direction, I think that's much more helpful. So forcing people,
let's be honest,
to do
masks in general are just so difficult. They don't affect our CO2 levels. We know that's
volume ratios.
They don't affect our O2. They don't affect that. But
there's been a lot of
they are brutal socially. They're brutal psychologically. Yeah. But at the same time, we know that they are pretty effective. And so we'll leave that as it is. We don't need to go into more detail on that one. Let's see. And somebody else did say, as we were talking about the government, that one of the great things was that the government got involved, and so the funding was really impressive from the government. The downside is the government got involved, and given that 70% of people don't trust whatever administration's in place, that conflation of government and pharmaceutical industry and vaccination or vaccine creation, I think, is what has some people hesitant here, and I understand that. But I would say going by the science. It's
some countries have some countries. I know the lab I worked in for my postdoc, the PI was Dutch, and there were some Dutch people in the lab, and one of the guys that I worked with went and worked for the government in the Netherlands, and he was in their vaccine department of the government, and they have like all the vaccines are made in these labs and given to the people, and it's sort of like an arm of the government. Maybe what we need to do is in our country is just separate out the vaccine group, from the politicians, and let those vaccine people do their thing, and give them some support. But I mean, that's what they do in some countries, and it seems to work pretty well. So one way or the other, it's public health policy. So people need to just think in public health is a very big deal from the very early days when they just figured out that, sanitation and water and all that stuff and disease and bacteria and these kind of things. And then viruses and vaccines were developed. And so we've gotten to a point now where we can really make some very effective vaccines, and we know how to test them. But still people have always been vaccine skeptical, all the way from Edward Jenner. They're like, am I going to turn into a cow? You're giving me cowpox? What? It just seems so horrible. But I mean, if you think about it, viruses are even more horrible. Yeah, that's the thing.
I have time, I think, for just one or two more questions, and one I want to offer to you as an immunologist and somebody, and from me as the person. Well, not I was going to say a nutritionist, that as somebody who teaches nutrition at Gordon, ornithology. Would you recommend that people, so perhaps in addition to vaccine, is there reason to also take some things like vitamin D, vitamin C, zinc, other compounds that might boost their immune system? Given that we are, and
that's an awesome question. I think we should end on this boost the immune system concept, right? So, so what you really want, I tell this to my students, and this is true. This is ask any immunologist, and they'll tell you, you really don't want to necessarily boost your immune system, okay, in a general way. Like, think about your digestive system. Well, what happens when you boost your digestive system? You might have diarrhea, right? I mean, so, you want it to function properly in a healthful way. You want it to be functioning properly. You don't want to amplify the immune system in particular, because you might have autoimmunity, right? You might become, react to your own body. And that's what can happen, in some disease states or in some states of disorders can happen. So to keep your immune system healthy, probably the number one thing to do is to lower your stress and get a good night's sleep. And, eat a balanced diet with all the vitamins you need. Most Americans have access to food that is plenty nutritious. Most people don't need supplements, as you probably know. I mean, but some people, will need vitamin D supplements or They don't necessarily harm you at all. So I don't think the taking of supplements is going to really boost your immune system, but anything that makes you rest and makes you feel better about your life and lowers your stress level is going to really make your immune system function as God intended, as it should function, which is making those antibodies against your pathogens, right? So we all get sick when we get tired, right? You run down, lack of sleep, you get a cold, and it's because our immune system is depressed when we're overtired. So what do you think? Was that good advice, Dr.
That was good advice. And I think, some of the compounds that somebody might be willing or might be interested in taking, like vitamin D, many of us have a deficiency individually.
Yeah,
and so absolutely, that would not be a bad idea. Vitamin C, if you're getting plenty already, more doesn't necessarily help, or you're just making yourself some pretty expensive urine.
Yeah.
Others like zinc, absolutely. If again, you feel like you are short, absolutely, that's where a multivitamin or something like that might be handy. But taking an abundance of a single supplement would not be wise in any way. I think you're right. It's better to take care of ourselves, get the vaccine so that we can't have those corrective measures for something like this that's a foreign invader into our bodies. We have hit 8:30, and while there are a few questions left, I think this is a good stopping spot. Your voice is probably raw, Dr. Story. I've got some lectures to get ready for tomorrow.
But mine are already.
I want to encourage people to be thoughtful and to be careful. We care about all of you, our students and faculty and staff and our friends of Gordon. We care about all of you, and we want to make sure that you're safe. And related to that, I mentioned the scientific enterprise, our course earlier, where we really try to get students to think about what science is and how important it is to evaluate work and to not go for confirmation bias, where you're simply looking for somebody to say what you want to hear. And this vaccine has shown us that we need more science in our lives. I think, Dr. Story, I would imagine you agree as a scientist that having just more knowledge is helpful. And I think that's where this was so helpful for me tonight, to hear from you, Dr. Story, about what the science of this really looks like. And then that allows us to make personal choices and allows us to also, push back against the government or not, or, mass mandate or not. As long as we know the science, that helps our decisions to at least be more thoughtful. So I really appreciate your comments and thoughts tonight, Dr. Story. And I
Thanks for leading the questioning. You did a great job. And I'll just say, if people have final questions that didn't get asked, they can just email me or you, and we can do our best to answer them.
Yeah, absolutely. We'd be totally into that. And you might not get a response immediately, but we'll try to get a response to you soon. And again, do your best to evaluate, looking for good sources, go to good websites. Don't rely on Facebook. There are a lot of people out to do us harm, and it's dangerous. It's a pretty dangerous place at times. So let's do ourselves good. Absolutely. All right, Dr. Story, thank you so much for your time tonight. It's been a lot of fun to see you on Zoom again. We're all sick of Zoom, aren't we?
I like it.
But absolutely, friends of Gordon and parents and students, I'm so thankful that you were able to spend some time with us tonight. And students, go study, but thank you to the students as well for their hard work this semester and for being such good people. Really appreciate that. All right. That's all we have. Really good seeing all of you. So long.
Good night.